Hello, is it
Yes,
visible?
sir. Yes,
Okay,
sir.
fine. So, in this presentation, I'll show you how to do uh, analysis with time series data. Time series means something collected on accordance to the time. Okay. So, before going to time series analysis, let us know about what is data. Uh, Data means anything, any numerical representation or any collected value which can be represented by some numerical value or uh, some categorical order are called data. But normally what generally do, statistics always need numerical data. Numerical data means there should have some valid numerical value on which we can use some kind of statistical analysis. In the last class, you have also seen that you are doing any kind of analysis. It may be chi-square, it may be t-test, it may be on another f-test. All these tests are done on the numerical data. So to do any kind of statistical analysis, first of all, we have some numerical data. Or some case, if we do not have that kind of numerical data, we have to convert or we have to do some editing to make the data in numerical order. Here we can see to quantify uncertainty in social science research, investigators have to do with different types of data. Already I have told you that your data set may not be numerical, but first of all, you have to do conversion or editing to do your data set, which may not be in numerical form. So data are the basic input to any decision-making process. Any records, descriptive account, or symbolic representation of an attribute, event, or process may constitute a data point. Data are usually measured on a numerical scale or classified into categories that are numerically coded. Appropriate use of statistical procedure requires that we understand the data and the process that uh, generated them. Actually, what we do analysis is that because we have to get some proper conclusion or some type of conclusion that everybody can understand. Because by seeing a data set, we cannot give some interpretation. And that point, statistical comes into view to help the researcher to get some kind of conclusion or some kind to help to make some interpretation which are easily known or easily understand by all people. So based on the source of data, we have two categories. One is called primary and the other one is called secondary. When we collect data by ourselves or by some individual, then it is called primary data. When just like door-to-door investigation, or if you want to collect some data from the source directly, then it is called primary data. On the other hand, the data which are gathered already in the form of some booklet, in the form of some code book, in the form of some Excel sheet, or you may find some data set in internet also in code book. These data are already collected and gathered and presented in some reputed way. Then those data sets are called secondary because here uh, we collect data from the secondary source, not from the respondent. Okay. So based on the classification and their type, we will have two type of data. One is called qualitative and the other one is called quantitative. Just for example, in case of qualitative, we have categorical data set like gender. We will have two category here or two to three category like male, female, or other. Other months, transgender also are coming into place. For example, eye color. Eye color means sometimes it is appear that eye color is black, sometimes it is brown, So ethnic origin, nationality, these are some example of qualitative data. But we first have to make this data set into quantitative one. Like uh, if I ask you a question that what is your gender, you will answer me like I'm male, I am female. But computer as well as statistics doesn't work with this qualitative data because means we cannot work with the male word. We cannot work with the female word. In that case, we have to code them just like 0 or 1 for male, 2 for female. In that, we will gather some numerical data set. On the other hand, in case of quantitative data, we will have some measures like age. What is your age? In reply or in answer of this question, you will mention some numerical value, right? Blood pressure. We will have systolic and diastolic, two types of blood pressure generally we have in your body. But when we ask what is your blood pressure, then you will answer me with two values. One is for systolic blood pressure, one is for diastolic blood pressure. You may say 114 by 84. Okay, this is numerical. Height, you may say 6.8 feet. Weight, what is your weight? You may say 84 kg. This is numeric. But when we gather some data in qualitative manner or in qualitative type, then first of all, we have to make them quantitative. By observation, again, we have two types of data. One is called discrete, one is called continuous. Just in the last slide, we have mentioned about height and weight. These are called continuous data. Why? Because these data are some, these data are gathered with the help of some predefined scaling procedure. Because you have seen the measurement, how we measure the height with some meter scale, like with some centimeter scale. You will get some scale for this. And for weight, you will have 40 kg, 60 kg, 70 kg. That kg was predefined. Okay, but discrete data are those which are collected in numbers, like how much cigarette do you consume in a day? In that question, you will answer that maybe some of you are smoker or maybe some of you are non-smoker. But if a smoking person was asked, smoking person is asked that how much cigarette you consume, you will tell some number, right? Like 5 cigarettes, a packet of cigarettes, 2 packets of cigarettes, or 15 cigarettes, like that. Now, the question is, how many accidents took place in your area in last 1 year? You will get one value, maybe 25, maybe 35, maybe 1, maybe 2. These are not in scaling procedure. We haven't used any kind of predefined scaling procedure here. So it is called discrete data. Now, by arrangement of the data set, we'll have three different types. One is called time series, one is called cross-sectional, and the third one is called pool data. Now see this table. Maximum temperature of Dibrugarh from 1st March to 10th March 2020. It is an example of time series. Why? Because we are gathering data of maximum temperature against a time value. In the first row, it is seen that 1st March 2020, the maximum temperature is 27.7 degrees centigrade. For 2nd March, it is 30.3 degrees centigrade. 3rd March, it is 31.1 degrees centigrade. Here, we are gathering the value or gathering the amount or gathering the measurement of temperature of maximum temperature against some time value. So this is an example of time series where we gather data in accordance to the time, then the data set is called time series. Again, see the heading, maximum temperature of 3 districts of Assam on 1st March 2020. In the previous example, we have taken only one district, Dibrugarh, and we collected data in accordance to the time. But in this case, we have one time. Time point is 1st March 2020, right? And we are collecting data for Dibrugarh, Jorhat, and Guwahati for different 3 locations. Here, the difference is that we have one time point and we are gathering data for 3 different stations. This type of data set is called as cross-sectional data. Maximum temperature of 3 districts of Assam from 5 March to 10 March, an example of pool data. When we together use time series and pool data, cross-sectional data, then it is called pool data. In the first example, we have taken only this column, and this column, right? In the second example, we have taken only the row-wise data set. First example, when we consider time and the location, then it is called time series data. When we consider the first row, that is one time point and 3 station, then it is called cross-sectional data. And together these things is known as what? Pool data. So now come to the point, components of time series. So is it visible? So there are 4 components. There are 4 components of time series. Okay. You probably know about that. First one is called trend. Second one is called seasonal. Third one is called cyclical. And fourth one is called random. Okay. Now I'll show you what it is. Say the first one is trend. When we have a data set and we put in a graph like frequency and time. If we put the frequency and time in this way, and if we get a line like this, then it is called trend. Trend is a long-term variation that may be exist in a time series data set. Okay, when we put some frequency like there are 2 things are here. One is time, one is frequency. Okay, say 1971, 1972, 1973. Now we are getting production of some maybe production of rice, 120 kg, 135 kg, 136 kg. And if we put these things in here, then it is appearing like a line. say here 190, 71, 72, and 73 like this. And this is say 120, 135, 135, and this is 136. We will get some line in upward direction. This kind of this graph or this kind of tendency in the data set is called having a trend in upward direction. Okay, if the line is in upward direction, then it is we say that this is there exists a upward trend. On the other hand, if the graph after putting the frequency against the time, if you are getting a graph in this direction, then we say that the data set have some downward trend. Okay, because here the difference is this: here the graph is in upward direction, here the graph is in downward direction. Okay, this is the example of trend. Again, seasonal variation. Second one is seasonal variation. Say for example, now the temperature generally high in the month from April, March to September. Okay. Again, temperature goes down from October to February. And during this period, when the temperature goes up, the purchasing or selling of the item, just like cold drink, ice cream, are increases. Right? Cold drink, ice cream are increases. Cream are increases. But when the temperature goes down, we focus on purchasing of warm clothes. Right? Now, you may see this difference that one is increasing, other one is decreasing, appears within a period of 12 months. Within a period of 12 months. If this kind of process appears within a 12 months, then it is called seasonal variation. Seasonal variation of the time series. Okay. Again, I am saying if any kind of variation in a time series appears within a period of 12 months, then it is called seasonal variation. On the other hand, if this type of variation appears in more than 12-month period, then it is called cyclical variation. When it is appear within 12 months, then it is called seasonal. When it is appear more than in 12-month period, then it is called seasonal variation. But both seasonal and cyclical, both are called period. Period. Both are called period. Seasonal and cyclical, both are called periodical variation. Okay. And the fourth one is called random variation. In general, we cannot find this type of variation, which is called random variation. You may see the production of, suppose we are taking an example of production of the car. It is well known to you that during the period of COVID, the production of car is going down. But before 2019, before 2019 December, or you may see, say, before March 2020, none of the company had that idea that COVID-19 will come in that way, and they have to minimize their production. So we cannot predict this kind of variation. And in a time series, if we find some variation which we cannot categorize in trend, cannot categorize in seasonal, cannot categorize under cyclical variation, then we called those variation as random variation. We cannot predict those type of variation, and we cannot estimate, we cannot forecast those type of variation, because before COVID-19 or before March 2020, none of us have that idea that COVID-19 will appear, we have to come home early, or some kind of quarantine, some kind of lockdown will be appear, production will be less, production, we have to make our production much lesser than the previous year. No, nothing. So we cannot predict, cannot forecast, cannot have an idea of random or irregular variation. So, but in general, a time series must have any kind of this any of these three components: trend, cyclical, and seasonal. In time series, we first have to check whether there is any trend in the time series. Okay, trend is not. Cyclical, is there any cyclical variation there? Is there any seasonal variation there? Because most of the time series techniques need a stationary time series. What is stationary here? Stationary means if a time series do not have trend, do not have cyclical variation, do not have seasonal variation, then the time series is called stationary. So the most of the techniques of time series analysis, or you say most of the test in time series analysis need to be a stationary one. The data set to follow a stationary one, and that stationary will be possible when there is no trend, no cyclical component, or no seasonal component. But in general, we cannot find generally this kind of time series where these three components are not available. In that case, we have to subtract or differentiate the time series so as to minimize the trend component or cyclical or seasonal component. I'll show you how to do this. So now let's come to the practical part.
Sir,
Yes.
can you please explain again the cyclic variation?
Oh, yeah, sure. Generally, in your book, you will find a graph like this. Okay. Here, 1 point here, and 1 point here. So this is the beginning. This is the beginning. Say, what I say? Say some company, name some company of automobile industry. Say Suzuki. Suzuki company. Say in 2018, they produce, this is some arbitrary value, they produce 50,000 car. 50,000 car in the year of 2018. And this is the value 50,000. Okay. But after 2018, 2019, 2020, 2021, 2022. In these 3 years, later part of 2019. So in this three year, COVID pandemic had occurred, right? COVID-19 pandemic had occurred. And due to this, in this year, say in 2019, this is 2018, okay? In 2019, say it gradually decreases from 50,000 to 47,000. Okay. Then in 2020, it comes to 25,000. In 2021, it again dips to 20,000. 2022, now the COVID lockdown was removed, and gradually people are coming to the market, and they are in the sense that yes, we have to, now we can buy a car to wander here and there because there is no lockdown when we can travel with our one. So they are in the sense that we may purchase car right now. So it again goes in upward direction. In 2023, each and every lockdown or quarantine procedures are moved up. So they again purchase 52,000 car in the year of 2023. Now see the pattern. First, it is in here, gradually decreases, and now it appears into this part. It is a complete cycle. This this point, this point, it is high, then it is gradually decreases, and in the year say 2021, the production is lowest as compared to the 2018, and then again it appears to a gradual increasing point, and then again it made a point 52,000 in 2023. It completes a full cycle. In this, it completes a full cycle because from 50,000 up to 52,000, it covers approximately 6 years to come the point where it starts. It starts from 50,000, gradually decreases to 20,000, and again comes to 50,000 or 52,000 at the point of 2023. This kind of things generally happens more than a period of 12 months. For completion of this cycle, generally the data set or the process needs more than 12-month period. That's why it is called cyclical variation. On the other hand, in case of seasonal variation, you will get the same value or approximately same value or approximately same kind of variation within a period of 12 months. So it is called seasonal variation. But the both cases, both are called periodic event. But period to period, it will change. Is it okay?
Yes, sir.
Okay, fine. Now come to the data set. It is a time series. Why? Because the first column shows years. Second column is for January, February, March, April, May, June, July, August, September, October, November, and December. Okay. This is a time series data set. And this is a time series data set for total rainfall in each month. The first column refers to the year, that is the time. Second column refers to the value of the rainfall for the period of January month. It means in the year 1971, the total rainfall in the month of January is 56.9 mm. In general, we measure the rainfall in mm unit. So in 1971, the rainfall for January is 56.99. In general, what we do, we in time series analysis, we want to check what is the trend, what is the seasonality, what are the cyclicity that maybe exist in the time series. And then after knowing these things, we do necessary techniques for what? Forecasting purposes. Okay. But you have I think you have gathered the idea how to construct dataset in SPSS. I'll show you once again. So this is the SPSS view. I'm using SPSS 27 version. You may use some updated version or some earlier version also, but the analysis will be same. near about same. So this is the year and this is the month-wise value. Now we can use these things to draw time series dataset or time series calculation. On the other hand, you can put a time series. Okay, I'll show you how to do these things. Okay, this is the average rainfall. Okay, and then this is the same data set as of this. Okay, this is in Excel. I merge this column and put in this way in SPSS. Now to use time series analysis, first we have to have data set. This is only a data set, an ordinary data set. Okay, because this is not a time series. Why? Because there is no time point available in this data set. Because only then we have to go for data, define date and time. Okay. There are options years, quarters, years, month, years, quarter, month, days, weekdays, etc. But what our dataset was, we have years and we have the month. So we will choose years and month. Okay, we have choose years and month. Now check the original dataset. It starts from 1971 and ends at 2015. Starts at 1971 and ends at 2015. So here we will select 1971 and we have 1 month. Starts from the January, so we put here 1. By default, it is always 1. So press OK. Now, sorry, it is not here. This one. Originally, there is no time options are here. We have get three different column. One is year, second one is month, third one is date and month. Because this reflects this data set is from this data point is from 1971 of first month. Together, this means January 1971. So 56.90 is for January 1971. Then check it, 56.9. This one, and here, 56.90 is for January 1971. Are you getting my point? Do you need the data set right now to do these things in your own way? Hello, sir.
Sir, hello.
Yes.
Yeah, actually, in the SPSS, how to
Yeah.
actually incorporate this data means only you have taken the average value. So just copy paste this on SPSS. I just missed the part. That's why I'm asking.
Oh, okay. This one.
No, the first column in the SPSS average value.
No. Just wait. See, uh, this is 1971 year,
Hmm.
and you
Hmm.
will have 12 different value, right?
Yes.
Now you can copy paste from here to the SPSS. It is also okay.
Total
Okay.
database.
On the other hand,
Okay.
if you
Achha.
need the raw data set, as like I am
Hmm.
using here the only the raw data set, not average. Okay.
Okay. Hmm.
Okay. I'll rewrite the name. Okay. Okay. In that case, you will have you can use some shortcuts, or on the other hand, you can do some uh, extra calculation, like you will have to copy these things.
Hmm.
You will have to copy these things. Okay.
Yes.
Now, mm, just copy again, and then use paste spatial. After
Okay.
clicking the paste spatial, you will have our option transpose in the lower part. Click on that and press OK. Okay.
Yes,
Now,
sir.
what happened? Now, what happened? We will get some data set like this. And now, this column refers to this row. Are you
Okay.
getting my point?
Yes, yes,
Really,
yes.
our data set is in row wise. Now we make it as column wise.
Okay. Fine.
Okay.
Yes. Hmm.
Then after, you can do some extra calculation by using some shortcuts. It is also possible, but I'm showing how to do raw calculation. This is for 1971 year. Again,
Hmm.
you just cut and put here. This is for 1972. In that way, you can cut and paste here to make one single column, just as I make it here.
Okay. Okay. I got this point. Yes. Thank you.
Okay. And anyone, you need this data set right now to do the calculation, or you can use this data set after the session also. But if you want to do these things, because I prefer to use the statistical calculation together with my teachers, because otherwise you will forget the things. Or if this class is on record mode, then also it will be okay. I want to hear from the sir actually. Pushwaha sir, are you there?
Yes, sir.
Uh, is it necessary to give the data set right now to the students?
Sorry, sir.
Is it necessary to give the data set to the students right now? Or after the class, I can share the slides or the data set. Is it also okay?
Anyone? Fine, fine.
Okay,
No
okay,
issue.
fine then. Any question from the students? If you have any question till now, then you can ask. Okay. Now come to the SPSS again. Now we have a time series because we have the rainfall, we have the values for the rainfall, and we have the time for the values for each values. Now go to the analyze. There is a point forecasting. Uh, all these points won't be there in your SPSS, because if you are using 29 version, then some one or two options, more options are available here. Apart from these 8 options, another 2 options may be available in your panel, or if you are using earlier version of than 27, then some options may not be there. Okay, but I think you have seasonal decomposition. Okay, go to the seasonal decomposition and you will have 3 different parameters here. One is rainfall, one is year, one is month. But see, the date is not here because to do this kind of decomposition or do this kind of statistical technique, you must have some data set which are measured in scale. So in measures, you will find 3 different scaling procedures. One is called scale, one is called ordinal, one is called nominal. I think you have learned about this. Do you?
Yes, sir.
Okay, fine. So to do seasonal decomposition, your variable or your parameter must be in scale. Your data set must be in scale. So go to the forecasting, seasonal decomposition, and select the rainfall. And then there are 2 types. One is called multiplicative and one is called additive. If your component is in a multiplicative order, then you have to select multiplicative, or other hand, you can see select additive. But it is not necessary for right now. So by default, it is multiplicative, moving average weight, all points are equal, and then press OK. The specification with the 4 variables. Here a message is appeared. The specification would add 4 variables to the data file. OK to save all the 4 variables. I'll show you what will happen. Press OK, and this is the output. Model description, model name. It is a model name which is placed by default in the software. Model type multiplicative. We will select also additive model here. Series name rainfall. Length of the series 12. Why? Length of the seasonal period 12. Why? Because we are using 12-month data set. In each year, we will have 12 different months. Computing method of moving average, span equal to the periodicity and all points weighted equally. Span equal to the periodicity means the length of seasonal period here is 12. Why it is 12? Because we are gathering data set where 12 months for each year are given. So we have used 12-month periodicity here. 12-month periodicity and weighted moving average is here. I'll show you what is moving average in short. Say we have 1971, 72, 72, 73, 74, 75. We have data like 25, 23, 21, 34, 45. So this is a time series data. Now we need 3 yearly moving average. We need 3 yearly moving average. Okay, then what we have to do, we have to sum up this 25, 23 plus 21 divided by 3. Again, sum up these things, 23, 21 plus 34 divided by 3. Again, sum of this 21, 34 plus 45 divided by 3. And the value of this is known as moving average of order 3 or 3-yearly moving average. Now, by seeing this value, we can see whether the time series is increasing or decreasing manner. I'll add distinction, show you how much. 25 plus 23 plus 21 divided by 3 is 23. 23. Okay, 23 plus 21 plus 34 divided by 3 is 26. 21 plus 34 plus 45 divided by 3 is 33.33. Now, if we put these things in a graph where here it is time and here it is frequency, then here 71, 72, 73, 74, 75, and we will have value against 72 is 23, and in against 73 it is 26. Then against 74 we will have 33.33. Now if we draw a line joining this 3 point, we will get a line like this, and this is what? And this is what? The trend. This is what the trend. Okay, because the line is in upward direction. This is a way to calculate how the time series is behaving. Okay. Now come to the SPSS. So this is the seasonal factor. Period 1, 11.4. Period 2, seasonal factor is 21.9. Period 3, seasonal factor is 32.22. And if we see that period 5 means month of May, period 6 means month of July, June, period 5 means month of May, 6 means June, 7 means July, 8 means August, 9 means September. In these 5 months, the rainfall is increasing. As compared to what? As compared to the month of October, November, and December, and April, March, February, January. As compared to these 3 months and these 3 months, this 4 months and these 3 months, the another 5 months appearing high rainfall. Okay, are you getting my point? If you find any difficulty, I'll show you once again how to do these things. First, go to the analyze, go to forecasting, then seasonal decomposition, go to rainfall, insert the value rainfall, then press OK. And we will have this type of output. And again, come to the data view, you will get 4 different factors here. 4 different factors here. I'll show you what is the 4 factor refers. These are the 4 factors. 5 factor. What is this? Seasonal adjusted series for rainfall from season. Okay, means In the first in the first half of the class, I have told you that your time series should be stationary so that to use a what any kind of time series techniques. So here this is a seasonally adjusted time series which are getting from this rainfall original data. Now the second one is seasonal factors for rainfall from season model and Newell equation. Then error for rainfall, and last one is called trend cycle for rainfall from season and model. So we can put some graph from these four factors. Like if we see in the graph, okay, I have inserted here, that is our original time component here, and inserted the trend cycle here. Will help a graph like this. Okay, this is the graph from what? Trend cycle for rainfall from season. Seasonal time cycle. Here you can see these are appearing. Some peaks are appearing, right? When? In 1972, in 1980, again in 1985 or somehow. So in this period, the rainfall was happen in some increasing manner as compared to the other values. Okay. Again, we can put some graph for other value also. See here a seasonal factor. Just click and drag to here x-axis. Just click here and drag to the y-axis and then press OK. So this is the seasonal factors for rainfall from season. Now you can see why it is called seasonal factor, because it is appearing in same manner from one season to the other. Generally, the seasonal variation which may be exist in a time series should be like same with the data set, because in 1971 the graph is same as of 1971 or 1972. Again 1980, the graph of 1980 is same as of 1981, 82, 83, like that. Okay, how we get this data set? How we get these results from this original data set? At the beginning, we have only this column. We made this column as time series data by introducing these three column. How? By converting to data to a new data set that is called time series data. Then by analyzing, by using the what? By using the seasonal decomposition, we get another four columns, one for seasonal adjustment, one for trend. And then we got four different columns. And by using the graphical procedure, we can analyze what type of trend or seasonality or whether there exists seasonality, cyclicity, or trend in the time series or not. By using graph, you can see this. Okay. Next, spectral analysis. Now, we may check what is the periodicity exist. What is the periodicity exist? It may be, again, I am saying in the beginning, I have told you that periodicity may be of two categories. One is called seasonality, other one is called cyclicity. If the distance of the period is more than 12 months, then it is called cyclic component or cyclicity. If the distance of the period or the occurring of the period is less than 12 month distance, then it is called seasonality. Now, if we now our main aim is to check whether there is any kind of periodicity exists or not in the time series. Again, I am saying at the same point, question is saying what is the length of the periodicity, but by knowing that result, we will have two different conclusions: whether there is cyclicity exists, whether there is seasonality exists or not. Here we inserted the rainfall, that is the original data, and then by using, you will have different methodology here: two-case Henning, Pargen, Bartlett, Daniel, and the test. Okay, and then center variable. Now, if you want to have the plots, then you will have the option of periodogram and spectral density for 2K Hamming. By frequency, by period. We need the value by frequency, so, or we need the value by period, then we place OK. Now see what happens. Periodogram of rainfall by period. See, this is the periodogram. Periodogram means something the data set in frequencies approached. Okay. Now it is spectral density, and this is periodogram, and this is the result. Now here it is written as model 9, and it is univariate. Why univariate? One variable is there. What is the variable? Rainfall. Reduced by centering at 0. What spectral window we are using, or what method we are using? 2K Hamming. Window span is 5, means we are getting a 5-month periodicity here. So weighted value 2.40. This is not necessary so as to our concern. And this is the periodogram: 2.0 E7, 4.0 E7. Now, what is 4.0 E7? E7 means exponential of 7, means the after before 4 you will have 6 0, means 0.00 0.60, then 4. Right? Yes. I'll show you how to do calculation here. Here it is 2.0 e to the power 7, means we are getting a periodicity which is greater than 2.0 e to the power 7, because 2.0 reflects in this line, refers to this line, and some value is sometimes higher than 2.0 e to the power 7. 2.0 e to the power 7 means 1 divided by 1 divided by 0.2, which is equal to 5. So which means you have a periodicity of 5 months, which is appeared here. Window span is 5. Okay. Your periodicity is 5 means your data set has means data set has 5-month periodicity. 5-month periodicity means since 5 is less than 12 implies what? 5 month is the 5-month distance or 5-month seasonality. Seasonality. Okay. Are you getting my point? Hello? Anyone who is it bit tough?
Sir, this step is not clear for me.
Which one is? Periodicity?
Yes, sir. How it get from what option?
Okay, I'll show you once again. Go to the analyze. Forecasting. Spectral analysis. Originally, rainfall will be in the left-hand side. I inserted here. Span, you can use 5 here. You can use other test also, Bartlett. Then you can have the option of center variable. By plotting periodogram or spectral density, you will get some frequency approach and biperiod also. In the last one, I used biperiod. So I will show you the both ways. By putting this, we will have two graph. One is called periodogram, one is called spectral density. Okay. Again, I'll show you. After that, I'll okay, this is periodogram by frequency, and this is the density function. Okay. Now this is the function when it is by period, and this is by frequency. Now see what is your highest frequency here. Highest frequency is somehow greater than 2.0 E, right? Your highest frequency is here. Two frequency line are written: 2.0 e to the power E7, 4.0 E7, and your highest frequency is in between 2.0 E7 and 4.0 E7. If we calculate now, how we can get the how we can have the idea the what month is how much your periodicity, what is the distance of your periodicity, then you have to divide this value or divide 1 by this value, means 1 divided by your value, and this is distance. or period of oscillation. Period of oscillation. Now, if I divide 0 by 0.2, what will my value is? 5. So, which is your period? Which is your period? Means your data set have 5-month periodicity. Since 5 months is less than 12 months, right? So we call it as seasonality. Seasonality. We call it as seasonality. Are you getting my point? First of all, you have to go analyze, then forecasting, then spectral analysis, then insert your targeted variable, use any test statistical from test statistic from here, then your span is 5 by default, then use periodogram and spectral density, then by putting frequency and select frequency and press OK. You will have this type of window and then check what is your highest frequency, in which band it is falling. Since it is in between 2.0 to 4.0, so we use 0.2 as your 0.2 as your frequency level, and then by dividing 1 by 0.2 we get 5, which means your data have 5-month periodicity. That 5 month is less than 12 months, so we say at 5-month seasonality exists in your data set. Now, is it clear to you?
Yes, sir.
Okay. Next, sequence chart. Now, insert the rainfall here and then here in the time axis. There are some options, timelines. You can use these things also. But first of all, we won't use these things. First of all, just select the rainfall, then time axis level. And if we need this transformation, we'll do after seeing the first graph. One chart per variable. Okay, press OK. Okay, this is the original time series. This is the original time series. When you do research by using time series analysis in your dissertation, in your paper, you have to draw a graph like this at the beginning of your analysis. Okay, at the beginning of your written of the paper or written of your dissertation, you have to put a graph of raw time series data. Okay, this is a raw time series data. But by seeing this data, we can neither conclude that there is 10 exists, there may be cyclicity exists, or there may be seasonality exists or not in the time series. But we can say that some of the peaks are above the 1000 point, but on an average, all points are in between 600 to 800 bands. 600 to 800. In general, all peaks are in between 600 to 800, but some of the point band goes 1000 to 1200 band also. This is the preliminary and first step graph. Next, Again, go to the check chart. Now take natural logarithm and see what happens. Now, when we use natural logarithm, we got a time series like this. Why we use natural logarithm? To make the time series stationary. I in the beginning I have told you that your time series must be stationary. Stationary time series means stationary time series means no trend, no seasonality, no seasonality, no cyclicity. When your time series is stationary, then only we can use time series techniques. Different time series techniques. When we have time series with stationarity, then only we can use other time series techniques. At this point of time, we are checking whether there is trend, seasonality, and cyclicity are uh, there or not. We seen from the previous example or previous analysis that yes, we have in our data set, we have 5-month seasonality. So now our work is to remove this seasonality from the data set. For to do this, we must have to take logarithm. On the other hand, we can use one-time difference. How we can do this? Go to the forecasting, go to the sequencer and difference, one-time difference. Now, when we do natural logarithm, we see that again there are some peaks are available in the data set, which is in between 0 to minus 2.5. But when your data set will be stationary, then you won't find this kind of some peaks. All data sets are gathered in the same straight line. So I will show you how it's look like. Select the one-time difference. Sorry, select the seasonal difference one time. Why? Because you find that your data set have 5 month seasonality. Then press OK. Now we see what your graph will be. This is your graph. Your data set are concentrated on 0.00. Okay, we'll use one more time difference. Go to the forecasting, use sequencer, and now this time use two-time differentiate. Press OK. Now see, your dataset is look like this. Originally, it is look like this. Okay, this is the original time series. The time series is in between, concentrated in between 0 to 800. Now we constructed a time series which is concentrated in between minus 1000 to plus 1000, near about minus 1000 to plus 1000. We have put two differences and which is like this. Now, if we use one difference here and one difference here, you will see what will happen. Okay, this is somehow looks good from the previous one. If we take, see, if we take, sorry, if we take one differences here and one seasonal difference here and press OK, then we will get this type of data set, which is look like a straight line. Data set which are in a straight line, somehow a straight line, concentrated uh, within a straight line, straight band of line. This is called differentiation. And this data set is stationary. Okay. Now autocorrelation. By knowing the autocorrelation, you can have the idea of how much data is concentrated with the point. Now, if we see, yes, this one. This is autocorrelation function, and this is the leg. You don't have to bother about this leg kind of things. Just remember, by seeing the autocorrelation, you can have the idea whether the time series is stationary or not. Now, by seeing this, we can say, no, our time series is not stationary. Why? Because your data set must be in between these two lines. This is the upper one is called upper confidence limit. The lower one is called lower confidence limit. If all the data points, this one, this one, this one, this one, if all the data points are lies in between these two lines, then only we can say your data set is stationary. This is a quite more complicated, I think, for you. So just without using this, you can also forecast by using for time series analysis. Go to the create temporal causal models. Can you check in your SPSS whether this points is available or not? Hello, can anyone check this? If you have the SPSS, am I audible?
Yes, sir.
Can you check? Okay. Okay, fine. Go to the analyze, forecasting, create temporal causal model. Data set specification, time interval. There are aggregated distribution, missing value, which is not necessary, and in general. Time interval is okay. It is years. Time interval is years. Build option, confidence interval 95% confidence. Maximum number of input in each target 5. Model tolerance valve. One means there is one error in per thousand inputs. Model option, extend record into the future. Fields, now come to the fields. Use custom coordinate inputs, rainfall, target here, and press run. No, this cannot be happen in this data set. So go to the analyze, go to the forecasting, create traditional model. Include rainfall into the independent variable and the time to the dependent variable. Okay, then press OK. So our model is ERIMA 0000011. This is a way how to use. ARIMA is a time series model which use to forecast the time series for future. Forecast means you have data for 1971, 72, 72, 73 up to 2015. If we predict some data for 2016, depending upon this value, or if we predict for 2017, 2018, but depending upon this existing value, then these values are called forecasting. Forecasting. These values are called forecasting. Forecasting is what? Depending upon the first value, previous or past values, if I, by helping with some kind of modeling, if we give some values for the ahead years, means we have data for 2015, if we put value for 2016, 2016, 2018, or maybe only for 2016, then it is called forecasting. And one model which is here in SPSS is known as ARIMA. ARIMA. The full form of ARIMA is autoregressive integrated moving average. Autoregressive integrated moving average. This is the name of the model, which is given by Box and Jenkins. Probably in 1984. I forgot the year. Okay. And here you see that this is the model ARIMA 011 000 and the prediction is look like this. This is observed data, and if you need the prediction also, then also it can be done here. Forecasting, create traditional model, and then plots, observe and forecasted, residual, PACF, and then residual autocorrelation, confidence interval for forecast values, and that's all. Press OK. You will get observe. It is not appearing here. No, we have to use some different data set for that. So this is the way actually why it is not taking, I don't know. So you have to put one independent variable here and the time variable here. And then also you can use the autocorrelation function, and autocorrelate you will have the ARIMA model for forecasting. Okay, I'll see what is happening here. Meanwhile, if you have any question, then you can ask. I'll show you. I'm checking why it is not appearing, why it is not uh, happening. But meanwhile, if you have any question, then you can ask.
Hello, sir.
Yes.
Sir, actually, in the beginning, you had shown a moving average analysis. So that is not regression, right?
That is not a regression, but if you see the mathematical formula of moving average, it is look like regression. The mathematical formula of any time series model is same as the regression.
Okay, sir.
Because wait. Is it okay?
Yes, sir.
Y equal to mx plus c. Okay. This is a straight. This is known as straight line equation. Straight line equation. Okay. But if we put like yt equal to mxt plus c, this is a time series. We are getting some yt time series value, some slope is there, some time series again, some time series is there, and one constant time. This is time series. And first one is equation of straight line. Second one is equation of time series. But both the cases, if we see from the regression point of view, then it is called what? Dependent variable. And this is called independent variable. Right? So in this way, every time series equation can be represented as the regression. This is happen also in econometrics. In econometrics also, every econometrics equation can be represented as a regression variable or regression equation.
Okay, sir. Thank you.
Welcome. Any question? See, if you are not asking your doubt, then how can I know whether you are able to understand these things or not? Because in this type of workshop, when we have some online view of you and online view of students and online view of teachers, then both the teachers and students can't understand what is happening actually. Because you may also do classes in your field when you are seeing your students, by seeing the eyes of the students and what they are thinking and what they are doing and what is there in their mind, a teacher can understand. But in this way, if I am not seeing your picture, I'm not seeing your status, how can I understand whether you are gathering my views, gathering my things in your mind or not? So if you have any query, any point of time, you can ask. And till now, if you have anything and if you find any difficulties, then you can put question on the chat box also. If you are hesitating to ask question by unmuting the mic, then also you can put some question in the chat box so that I can understand what you are thinking. So go to the analyze, go to the forecasting, create traditional models, and you insert the time variable as independent variable, insert the values as dependent variable. Okay, then go to the statistics, what kind of statistics you need, maybe stationary R square, mean absolute error, what are the things you find necessary, and display forecast. These all things should be included. Then plot, observe values, what is given to you, forecasted, which will be forecasting using your past values, that is forecast value, feed value, confidence interval, in which ways and how much your dataset or your forecasted value may be lie, and these things are included, and press OK. Then you will get this type of things. The first one is model description. We are using for January month also, the value of January month. The model type is ARIMA 000. Okay. And then we will have this type of things. This is observed value. This one is red color shows the observed, the original. Blue color shows the fitted value. And this dotted line is upper control limit and lower control limit. Okay, this is the forecasting. We will show you in the original data set also. Go to the analyze, go to the forecasting, go to the analyze, then go to the forecasting, create traditional model. Okay. Insert the rainfall in the dependent variable and time as the independent variable. Go to the plots, include feed values and confidence interval. Press OK, and then you will have yes. Now this is your graph. Since the data set is much higher than it is, so it is somehow okay. We have to copy to this in the Word file. So this is the graph. Red line is the observed value. Blue line, somehow you can see that blue line is the fitted value depending upon your observed value. UCL and LCL is the upper control limit and lower control limit. How we have done this, I'm showing you again. Go to the analyze option, then go to the forecasting, then create traditional models and insert the data variable to the dependent variable, insert the time period in the independent variable, go to the statistics, what kind of statistics you need, you have to mention here, then go to the plots, use the series, observed value, forecast value, feed value, confidence interval for the forecast and confidence interval for the feed values here. And if you put some output of flyer, then also you can use if you fix number phase. In this figure, you have seen that it is appearing in some way that you cannot describe this table. In this case, you can use base fitting models, fixed number of models that say say here percentage 50%. Now press OK. Now see what happens. Okay, from 1971 to 2012. I'll show you once again. Forecasting, go to the traditional module. Save, if you want to save the predicted values, UCL, LCL, residuals, and options. There are some options that first case after end of estimation period to last case in active dataset. You can also include these things in your output. But in general, you have to put the data variable in the independent and year variable or time variable in the independent and data variable in the dependent case. Then statistics, generally goodness of fit and R square is necessary. Stationary R square so that you can have that idea your model is stationary or not, and plot. Only use these things. Residual of autocorrelation and PSF is these are not necessary actually. And then upload file, this one, and save option. You click all these things so that these things are also recorded in the data view of your SPSS page, and then press OK. So simple seasonal model was established in this case, and this is the table. You have to include this table in your dissertation or in your paper. Model statistics, here the R square is 0.765, which means your data set is your model is fitting good, because whenever we have R square, generally R square lies between 0 and 1. Okay, when R square tends to 1, we say that when R square approaches to 1, we say that model is good. Model fitting is good. Okay. So, where was this? Yes. R square lies between 0 and 1, and when R square tends to 1, we say that model fitting is good. In our case, we see that R square is 0.765, which means our model is good fitting. And this is the graph which we are expecting. That is observed value is here and fitted value is here, and we are getting some UCL and LCL limit. And if you see the data set, we will find this one: predicted rainfall, LCL, UCL, and residual. Okay, and you can use these things also in Excel, because if you find this is some kind of graph that is we cannot write down interpretation or describe this graph, then you can have that option. You copy this data column, predicted, LCL, UCL, and then the original data set to the Excel, and then you can use the graphical option from the Excel also. Okay. Any question till now? If you have no question, then I can stop here for this class. Thank you.